Subject name Compiler Design Unit 2 for 3rd year 5th semester. Topic is Pushdown Automata PDA.
Pushdown Automata PDA. It's a mathematical model. It is the extension of finite automata. Definition. A deterministic finite automata is a finite amount of information, but a PDA is an infinite amount of information. And then basically a pushdown automata is a finite state machine, that is epsilon NFA, that is non-deterministic finite automata epsilon, and a stack. Both the combination is, we can call it as a pushdown automata. There are three components included in pushdown automata: an input tape, a control unit, and a stack with infinite size. Three components are defined by input tape. The input head is a read only and may only move from left to right, only one symbol at a time. And then finite control. The finite control has some pointer which points the current symbol which is to be used. That is, it may be the string. Stack. Push and remove the items from one end only, that is top of the stack. It has an infinite size to store the items temporarily. We know that the stack head scans the top of the symbol, that is, we can access any item from the top of the stack only. The stack does two operations, one push and another is a pop. A push operation, a new symbol is added at the top. Pop symbol, that is, the top symbol is read and removed. The PDA can be described with the 7 tuples, that is Q, sigma, S, lambda, Q naught, I, and F. Q is the finite number of states, sigma is the input alphabet, S is the start symbol, lambda is a transition function, that is transition values. What are the transition is happening inside the pushdown automata, that is Q into sigma U epsilon into S into Q, that is number of states, into S star. So Q naught is the initial state, that is the start symbol. Q naught, which is belongs to Q, that is number of states. I is the initial stack top symbol. What are the strings included at the top? That is I which is belongs to S, that is the stack symbol. F is a set of accepting states, F, which is belongs to Q. In the pushdown automata, the following diagram shows the transition of PDA from state Q1 to state Q2, labeled as A, B, and C. That is, so this shows the Q state, and next one is another Q state, that is start symbol to the accepting state, that is the end state. From start state, this Q shows Q1, and the next state shows Q2, which is here input symbol A we are given, and that is we are inserted, that is pushed into the stack. Whenever we are pushing the stack, that is that will be appear at the top of the stack only. Suppose if you want to insert the one more another symbol stack, that is B, we need to remove the symbol, previous symbol A. So that is pop operation. So we need to push the element A, that is string A, and the top symbol of the stack already will be B. If you are inserting the another value will be B, that is the top of the stack. If you want to pop B, that is the top of the stack, will be removed, and then we need to push the another symbol C, that is again the top of the stack. If you are pushing, the stack will be at the top of the stack. If you are removing, that is popping the element, that is also top of the stack. That is, we need to move from one state to another state, that is Q1. Q1 is a start symbol and another symbol. We are reaching the final state, that is a Q2.
Instantaneous description ID. ID is a formal notation of how a PDA computes an input string and make a decision that string is accepted or rejected. So by using this ID, we can conclude whether the PDA is accepted or rejected. An instantaneous description is a triple QW alpha, where Q describes the current state and W, we know that it's a remaining input string, and alpha is a stack contents, that is top at the left. In this ID, turnstile notation we can describe, that is turnstile sign describes the turnstile notation and it represents one move, that is turnstile star sign describes a sequence of moves. For example, we can say P, B and T, that is, so these three values will be turnstile Q, W and alpha. Q is the current state, W is the input string and alpha is the stack of the symbol. We can explain with the PDA for accepting a language A par n, B par n, which is n is greater than or equivalent to 1. In this language, n number of A's should be followed by n number of B's, that is equal number of A's and equal number of B's. Hence, we will apply a very simple logic, that is, if we read single A, we will push A's into the stack. As soon as we read B, then for every single B, one A should be popped from the stack.